Okay, hi there. So in this video, what we are going to discuss is how do we derive with the formula or with the general formula that we are using right now when we are solving for the value of the slope. And that is m equals y sub 2 minus y sub 1 over x sub 2. So x sub 2 minus x sub 1. Where did we get this general formula? So that is what we are going to find out later on using an illustration. Okay, let's say for example, this is our Cartesian plane. And in our Cartesian plane, we need a line in order for us to work on a slope. So to form a line, first things first, we need to have at least 2 points. So let's say this is our first point. Let's name it as point A. And our second point is, let's say this is point B. And these 2 points are just arbitrary. So it could be any points in our Cartesian plane. And since these are just arbitrary, then we will just be representing arbitrary coordinates for these points. So for point A, let's assume that the coordinates is represented as x sub 1, y sub 1. To mean that these two coordinates belong to the same point. While for B, let's say this is x sub 2, and then this is y sub 2. Now, if we will connect these 2 points, we will now be able to form a line. And you see, the slope of the line is also evident in our illustration. But how are we going to solve for the value of the slope of this line? So let's find out. Okay. Now, in order for us to do that, we must go back first on how we understand slope. And remember, we defined slope as the ratio of rise and the run. So this one will be useful to us later on once we are deriving on the general formula. But before that happens, I want you to see this important point in our illustration. Okay, so from point A going to point B, for it to arrive or connect with point B, it rises first at certain number of points before it runs. So there is a turning point here before it runs and locate point B like this, which forms the slope of the line. Now, let's name this turning point as point C. And let's find out the coordinates of this point C using an observation in our illustration. Now, look at point A compared to point C. We know that this point rises at a certain number of points or a certain number of units before it moved to point C, which means to say that these 2 points are vertically aligned. And since these 2 points are vertically aligned, that means that the x coordinates are just the same. Because look here, since it is just rising, so these 2 points are vertically aligned like this. Now that gives us the idea that point A and point C has the same x coordinate, because the changes only happen in the y coordinate. That is why the rise here is also denoted as change in y. So change in y, okay, like that. On the other hand, so let's use delta y instead, or change in y. Okay. On the other hand, for the relationship between point C and point B, it only runs in horizontal manner, or the changes happen in horizontal manner. So that means these 2 points are these 2 points are horizontally aligned, like this. And that gives us the idea that these 2 points has the same y coordinate. So this must be y sub 2, since point B has y sub 2 as its y coordinate. So we now have the coordinates for point C. Now, why is this helpful? Okay, before we deal with this one, okay, now I want you to know that this is the reason why the run is also denoted as the change in x. Because the changes only happens in the x coordinates. Because, or since y values are just the same. Because it is horizontally aligned. Okay? Now, how are we going, or how does this point C will help us in finding out the general formula? Okay, going back to this, so we have rise over run. And then we know that the rise happens because of the change in y. Now, how do we compute for the change of y? Let's have this mere example. Okay, let's say this is our horizontal number line. So here is our horizontal number line, and we are to look for the change in this point going to this point, or from 2 going to 4. So usually, aside from counting the number of units like this, 1, 2, another way to think about this is, this also refers to the difference between these two values. So 4 minus 2, that will give us 2. That means the distance between these two coordinates, or these two values, is just 2, which is correct. Now we will follow the same thought here when we are dealing with the change in y. So since we want to know the change in y, so that means, or the rise, so rise over run. So that means the rise is also the same as getting the difference between the change in the y values, or in other words, that is y sub 2 minus y sub 1. So that's the distance between these two. Now, on the other hand, for the run, that means we are to look for the distance from point C going to point B. And this change happened after the x values change. So same idea or same thought will be applied here. To get the distance between x sub 1 and x sub 2, we are to get the difference between the two coordinates. So x sub 2 minus x sub 1, that will tell us the distance between the two coordinates. And this now represents our slope formula. Now this time, let's interpret. Let's interpret what's the meaning of this formula. Look at the coordinates that we use. Y sub 2, y sub 1, x sub 2, x sub 1. These coordinates are actually, or basically, from our given points. Point A, x sub 1, y sub 1. And then point B, we have x sub 2, y sub 2. To mean that we can solve right away for the value of the slope if we know at least 2 points. So at least 2 points which lie along the line. Now, how do we use this formula? Let's say, for example, you are given 2 points. So let's have point A again. Point A is 2, 1, and point B is 4, 3. And let's assign, let's say this is x sub 1, then this is y sub 1, this is x sub 2, y sub 2, which will lead us in answering using our slope formula. Okay, so we need to assign who will be or which will be our x sub 1, y sub 1, x sub 2, and then y sub 2. But the big question is, can we interchange these two? Yes. And we will show that one as well later on. Let's say our y sub 2 here is 3. So 3 minus 1 as y sub 1 over x sub 2, 4, minus x sub 1 is 2. So that means your slope value is 2 over 2 or simply 1. Now let's try to interchange these two. So what if we interchange these two? So what if this time this is x sub 2 and then y sub 2? Take note, I'm using the same subscripts to mean that these two coordinates belong to the same point. So that is what must not happen, that this one is x sub 2 and then this one is y sub 1. Okay? And then we will have this as x sub 1, y sub 1 instead. So let's see if we will arrive with the same answer. So slope is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. So y sub 2 now is 1 minus y sub 1 is 3 over x sub 2 here is 2 minus x sub 1 now is 4. And the answer here is negative 2 over negative 2. And still, the answer is equal to positive 1. So therefore, we can interchange since these labels are just arbitrary. So any of the points could be x sub 1, y sub 1, x sub 2, y sub 2. What must not only happen is that one is x sub 1 and one is y sub 2. So that will technically be different. Okay, so that's it for our discussion about the slope. So I hope you learned something from this video.